Hi, Tom the Professor here. It's time for another problem. Let's get started. How about for this episode we do a little rocket science? I'll put the text on the screen if you want to try it out. We'll start with what do we know? Apollo 11's orbit around the moon, its altitude was 111 kilometers. The moon has a radius of 1,785 kilometers and a mass of 7.3 times 10 to the 22nd kilograms. Now in this problem, what we need to find is the time for one orbit at that altitude. This is actually going to be a pretty short problem, so let's just jump in here. When dealing with orbital periods and things like that, we're going to use Kepler's third law, which is derived from centripetal force and the universal gravitational formula. If you don't have Kepler's third law, you can always go back there and try that. But since we do, let's use it. The orbital period squared is equal to 4 times pi squared divided by the universal gravitational constant times the mass that's being orbited. So in this case, it's going to be the mass of the moon. You could do a similar thing with a satellite going around the Earth, but use the mass of the Earth in there instead. And then take that whole fraction times the radius of the orbit to the third power. Kepler's third law essentially says that the orbital period squared is proportional to the radius cubed. That's an easy way to remember that. Okay, we have all the numbers we need, so let's throw them in there. The 4 pi squared on top, 6.67 times 10 to the minus 11 on the bottom, times 7.3 times 10 to the 22 kilograms, which was the mass. And then we're going to take the two values for the altitude and the radius and combine them to get the radius of the orbit from the center of the moon. So we get 1,896,000 meters. So we'll cube that, and when we do that, take the square root, we get 7,433 seconds, or approximately 124 minutes. And with that, we've conquered another problem. If you have questions, let me know. Make sure you like and subscribe to the videos so that you can keep caught up with me. Send me a message on Facebook and Twitter at the handle on the screen. Check out the blog, tomteacheспhysics.com, where you can read about some other things I'm doing, and of course pick up yourself some merch. This is Tom the Professor, and I will see you next time.